let's proceed to our sample problem number 3. Okay. So the boxes, so natin given, no? The boxes travel along the industrial conveyor. If a box starts from rest at A, so if you can see the graph, this is point A. So it is starting from rest, initial velocity is 0, and increases its speed. So an increase in speed such that its A sub t, that is the tangential acceleration, is equal to 0.2 t meters per second squared, where t is in seconds, where time is in seconds. Determine the magnitude of its acceleration when it arrives at point B. So we were asked about the magnitude of its acceleration. And then natin given nga tangential acceleration. So can we use the constant kinematic equation to solve this problem? No, because this is not a constant acceleration. If you see the equation, the acceleration, tangential acceleration is 0.2 t. It means the acceleration increases through time. It is not constant, unlike the sample problem number 2. So, unsay buhaton na to, unsay gamito na to, kung dili constant acceleration, if you remember, we use katong naay mga derivation nga formulas. Okay? So, let's take note of the given. So, this is sample problem number 3. So, it starts from A. So, from A, paingon din nga point, that is 3 meters. So, this is a straight line. And then, niabot na rin ang curve dire. Okay? So, ang radius na to, so ato la i-write. Ang tangential acceleration na to is equal to 0.2 t meters per seconds squared. And then, atong radius or rho or r, it depends kung sa'yo mas comfortable ninyo nga gamiton, that is 2 meters. So, we were asked the magnitude of acceleration, this one. So, unsaan man ana to? So, we cannot use the constant acceleration formula. Therefore, we use katong naay mga derivations nga formula. So, again, diba, ato ang formula for the magnitude of acceleration, A is equal to square root of tangential acceleration squared plus normal acceleration squared. So, ato ang tangential acceleration is 0.2 t. Normal acceleration, if we recall, that is the v squared over rho. So, atong v, velocity is unknown. So, unsay relationship ni kani nga velocity with tangential acceleration. So, di ba natay acceleration is just equal to the derivative of the velocity with respect to time. So, from this formula, we can get the function of the velocity with respect to time. So, we write it here. dv is equal to a sub t dt. And then, our tangential acceleration, that is 0.2 t dt. Integrating both sides. So, it's starting from rest. So, itong velocity is from 0 to velocity. And then, from time, that is unknown. So, 0 to t. So, we have here the from 0 to v. So, the velocity from 0 to v, interval 0 to v. And then the integral point to t, that is 0.2, t raised to 1 plus 1 over 1 plus 1 from 0 to time t. So, simplifying further the equation, the function, this becomes 0.2 over 2 t squared from 0 to t. Or you can just simply write 0.1 t squared from 0 to t. So, v is equal to 0.1 t squared. So, this is our formula for the velocity, which we can use also here. And then, anon mangyapon ni unsa pa may lain na to makuha. So, if you recall that the velocity, yung relationship with the position s, is that velocity is just the derivative of the position with respect to time. So naa ba tay position nga makuha diri? Yes. So ato ang position is ang pag-travel ni particle or ni box from this point until this point. So from this point to this point, we have 3 meters plus pila man ang length ani. So this is a quarter circle. So if you remember, the circumference of the circle is 2 pi times the r radius. So that is 2 meters. But remember, this is the circumference. So mo na siyang whole nga circle. What we need to get is only the quarter of the circle. So kanina man nga part ang nag-travel, no? Say from A to here and then from this point to this point. So we divide this with 4. So S, the total position traveled by the boxes, 3 plus 2 pi r over 4. That is equal to 6.14159 meters. So, unsa may buhaton nato ani? Actually, ato ni siyang magamit for this equation. So, okay. So, we solve the position function. So, di ba natin velocity is equal to derivative of position with respect to time. ds is equal to v dt. And then, we know that v is 0.1 t squared dt. Integrating both sides from 0 to s, from 0 to time. So we have this 0 is equal to 0.1 over 3 t cubed from 0 to t, or just equal to 0.1 over 3 t cubed. So man ito ang position function. So we have here naman tayo s nga value nga 6.14159 meters. Then from this equation we can get the time. So substituting this value here is at 6.14159 meters. At 6.1459 meters, what is the time t? T cubed. So multiplying the whole equation with the reciprocal of this one para makancel siya. So we have t cubed is equal to 6.14159 times 3 divided by 0.1. That is equal to 184.2477 cube root of this equation. 184.2477. We got the time na the travel niya is 5.69 seconds. So time traveled niya from this point to here is 5.69 seconds. So humana ba ta? Wala pa. We were asked about the magnitude of its acceleration. So na tayo time nga 5.69 seconds. Therefore, we can solve for the velocity, and then we can solve for the normal acceleration, and we can solve for the tangential acceleration. Okay, unsa may una na to? Okay, let's start with velocity. So substituting lang the value 0.1 times t squared 5.69. So 0.1 times 5.69 squared, atong velocity is 3.238 meters per seconds. Ato ang tangential acceleration given by 0.2 times the times, that is 0.2 times the time nga 5.69. So 5.69 times 0.2. Atong tangential acceleration is 1.138 meters per second squared. And then our normal acceleration, kani v squared over rho. So atong v is, velocity is 3.238 squared over the rho, which is 2 meters. We have the normal acceleration equal to 5.242 meters per seconds squared. 242 meters per second squared. So we already have the normal and then the tangential acceleration. Then we can solve for the magnitude of the acceleration. So substituting the tangential and normal acceleration to this equation, A is equal to the tangential acceleration squared plus the normal acceleration squared. So we have the magnitude of the acceleration equals to 1.138 squared plus 5.242 squared, 5.364 meters per second squared.